In this video, we are going to talk about the different conformations of the molecule ethane. First, let's go over the word conformation and what is meant by that word. Conformation is a fancy chemistry word to refer to the shape of a molecule. So the conformations of ethane are the different shapes that the ethane molecule takes. It's pretty easy for students to confuse conformations with something like constitutional isomer. Try to not get those concepts confused. Conformations or shapes are different forms that the molecule can take without changing its identity. So for example, let's use an analogy. You as a person, I'm going to draw a stick figure here, you can freely kick one of your legs up into the air. And so these would be two different shapes or conformations of a human. And you kicking one of your legs up in the air does not change the fact that you're a human or change who you are as a human. It's just a different shape that you can take. Constitutional isomers, if we want to continue on with this analogy, if we were to take you as a human and turn you into a constitutional isomer, that would require us to do a little bit of disassembly, like maybe remove your head and attach it to one of your feet. So that would be constitutional isomers. You with your head sewn to one of your feet, you're not the same person that you used to be. So constitutional isomers are two forms of a molecule that are entirely different, and I realize this is a pretty morbid example. Conformations, though, are just different shapes that a molecule can take, and it can go back and forth from one shape to the other without changing its identity. So again, what we're going to be doing in this video is studying the different conformations of ethane. Now, what I hope that you have your model kit handy and that you can build a model and follow along as we go over the shapes of ethane. And so what I'd like you to do, assuming you do have your model kit handy, I would like you to build a model of ethane, but I want it built in a specific way. So I want you to take your two of your carbon atoms and connect them with a single bond. And you're maybe going to need to kind of twist those carbon atoms around a little bit to get the next part to work just right. What I want you to do is attach one hydrogen atom sticking up off of the carbon that's on the left of your model. And I want you to hold this model in your hand so that the hydrogen, carbon, and carbon are parallel to your table or your desk or whatever you're working at. And then what I want you to do, and this might require you to twist a little bit, I want you to add another hydrogen to the molecule, to this carbon over here, and I want you to add it so that it is pointing down, opposite in direction from the first hydrogen that you added. And again, I want all four of these atoms to be flat in a plane parallel to the plane of your table or your desk. So all of these, you should be able to set this down on the table, and all four of these atoms are going to be flat. And again, that might require you to twist one of these carbons a little bit to get the hole for the attachment to the hydrogen, to get that lined up just right. But once you have got this accomplished and you've got all of these atoms flat, they're able to be flat, then you will add your next four hydrogens, and you will see that on your left hand carbon, one of the hydrogens that you're adding is going to be pointing down and it will be sticking up at you. The other hydrogen atom will also be pointing down but will be sticking back behind this hydrogen right here. So you're not going to be able to lay it flat anymore on your desk. And then on your other carbon, you'll see a similar situation, but the hydrogens will be sticking up. So one will be sticking up at you and one will be sticking up behind. And that's how I want the model to be built. Let's take a look at this in mole view. So this is a representation of the model that you have built. It's going to have four atoms that are in the plane of the paper. The light green obviously is the hydrogen, and I'm just kind of rotating a little bit so that you can see the hydrogens that are sticking up and the hydrogens that are sticking down. So now we're going to go back to our model and we're going to draw a Newman projection of this ethane. And what I want you to do is sight down the carbon-carbon bond from the left-hand side of the molecule. So this means if you have your model built, what I want you to simply do is turn your model. You're just going to rotate your model so that you are now looking at it this way. And I want you to get it nice and lined up. Like, see how I've got the carbon atoms really lining themselves up. And this is what we're going to draw. This is the Newman Newman projection for this molecule. So we're going to draw the Newman projection over here. We use a small dot to represent the carbon in front, and that carbon has one hydrogen sticking up, two hydrogens sticking down, one to the left, one to the right. There's our back carbon, the circle. It has one hydrogen sticking down, two sticking up, one to the left and one to the right. So this is our Newman projection of one of the shapes or conformations of ethane. So what we're going to do before we can really start talking about the shapes, we have to define a new word called, or new term called, the dihedral angle. The dihedral angle for a molecule, and this is going to be very confusing, so just stick with me for a minute while we write this definition down. This is the angle between two atoms that are separated by two atoms. Angle between two atoms that are separated by two atoms. So I totally understand that that is very confusing when it's written in words. But let's break this down, because I promise you it's not that confusing. So let's go find two atoms that are separated by two atoms. Let's take this hydrogen right here, and I'm going to turn it green so that we can keep track of it. And let's identify that same hydrogen in our Newman projection. And then that's going to be one of our two atoms. And let's find another atom that is separated from this green hydrogen by two atoms. So here is our green hydrogen. We want to find two atoms that are separating it from something else. So both of the carbons would be two atoms that would be separating that green hydrogen from, let's say, this guy right here. Let's choose that guy. So this guy, let's make that one red. This hydrogen right here in red. Now we have found two atoms that are separated by two atoms. Where is this red hydrogen in our Newman projection? Well, we know it's on the back carbon, and we know because it's on a dash and we're sighting from the left, we know that it is on the left-hand side. So it's right here in our Newman projection. The dihedral angle is the angle between these two atoms. I know that's a lot. It's a lot to process, but we'll practice it quite a bit and you'll get it. So let's make a note right here. The dihedral angle is this angle right here. The two atoms, let's keep going with our color coding here. Our two atoms were the green hydrogen and the red hydrogen, and they were separated by two atoms, this carbon and this carbon. There's a lot of kind of crazy arrows going on there, but what is the dihedral angle for these two atoms? So this is just going to go back to your knowledge of geometry. This is a full circle, so that's 360 degrees. It's divided into 6 parts. 360 degrees divided into 6 parts. Each one is going to be 60 degrees. So this particular conformation of ethane has a dihedral angle of 60 degrees. And like I said, don't worry if this is feeling really overwhelming, because we're going to practice this dihedral angle quite a bit. This particular conformation, where the dihedral angle is 60 degrees, is called the staggered conformation. In the staggered conformation, the dihedral angle is 60 degrees.